Good day and welcome to Ford Academy. In this video, I'll be going through how to carry out an ordinary least squares regression using SPSS. Carrying out an ordinary least squares regression using SPSS is quite simple, so let's run over it. First, you have to have your data set intact. Well, there is no statistical analysis or data analysis without data. So here I have my data set with three variables: age, height, and amount. So next, we go over here to analyze, we click on it, then regression, linear. So for this data set, my dependent variable is age. So I'll move the age variable over to the dependent box, while I move the height variable and amount variable over to the independent box. You could have more variables than I have here, and it's fine to use more variables. So feel free to use more variables depending on your analysis, depending on what you are looking at. It is only allowed to reduce your variables when you find out that one variable or the other is causing an issue to your analysis. Then you can remove some variables. So over here we have method. We have the enter method. The enter method is the traditional OLS approach. There are some other methods such as the stepwise method, the remove method, the backward method, the forward method. These other methods allows you to add or remove variables based on certain statistical criteria. So for the stepwise method, it allows you to add or remove certain variables based on some criteria. The remove method allows you to remove variables that are not significant to the model. The backward method removes variables that are not significant to the model one after the other. The forward method ensures that only variables that are significant to the model are added to the model. So for this case, we'll be making use of the enter method. Then we'll move over to statistics. Here we have to check the estimate, the model fit, the confidence interval, and if need be, you can also check the Dublin-Watson statistic, the descriptive statistics. Feel free to check whatever box that is related to the data set or the analysis you are running at the moment. The estimates, the model fit, the confidence intervals are much more like the basic boxes that are meant to be ticked under the statistics. The estimate gives you the coefficients of all the variables. The model fit allows you to see how well the model explains the data. The confidence interval is very, very essential in statistics. You can check the Dublin-Watson statistics if you are concerned about autocorrelation, which is very, very useful when dealing with time series data. So here we go. Feel free to change the value under the confidence interval to whatever value depending on the confidence level you are considering at the moment. You could be considering 99% confidence level, 90%. So feel free to change it. Now over here to click on OK. After clicking on OK, SPSS is going to give us our output tables, a number of output tables, about 4. So I think another window has been opened. So let's just check. Yeah, another window has been opened here. So we have a number of tables here. Yes, 4 tables. So here the first table shows the method. So since we are using the enter method, the enter method includes all of the variables in the model. So that's basically what the first table is for. So here we have the model summary table. So where we have the R square, adjusted R square, and standard error of the estimate. The basic values to be interpreted under the model summary table for OLS regression is the R square and adjusted R square. So for R square, we have 0.530, which simply implies that 53% of the variability in the dependent variable is explained by the independent variables. So over here, we have our adjusted R square. The adjusted R square gives a more accurate picture when we have many variables. So here we have 0.437. And over here, we have our ANOVA table. Basically, ANOVA table shows if the overall model is statistically significant or not. And for us to conclude that a model is statistically significant, it has to range between 0 to 0.05. So here we have our value 0.023, which simply implies that this model is statistically significant. And lastly, we have the coefficient table. Over here, we have the unstandardized coefficient. The beta values here gives us the unit change in these variables once there's a 1 unit change in the dependent variable. So this simply implies, the value here simply implies that a 1 unit change in age will result in a 1.611 unit change in height. Meanwhile, a 1 unit change in age will result in minus 0.034 unit change in amount, which simply implies that the relationship between height and age is positive, while the relationship between amount and age is negative. So over here we have the significant value, also known as the p-values. So we have 0.1, 0.269, 0.047. Basically, the significant value is supposed to range between 0 to 0.05, just as I mentioned earlier. So from this output, we can see that only amount has a significant value. So in overall, we can conclude that age and height has a positive relationship but is not statistically significant. Meanwhile, age and amount has a negative relationship and is statistically significant. So over here we have a 95% confidence interval, which basically shows the range in which the true coefficient is likely to lie. Thank you for watching.